Good morning, everybody. So today we are starting at Unit 3, and Unit 3 is on functions. So you'll notice that this is titled Relations and Functions. Our daily learning target is that students will be able to determine whether a given relation defines a function. The language target is students will be able to verbally justify why a relation is or is not a function. And then why am I learning this? This is important for real-world problems, like showing finishing positions and scores in a track meet. The candy machine analogy. Okay, so if you put your money into a vending machine and you select B2 and a Snickers bar comes out, your input is B2. That's what you punched on the vending machine, and the output is the Snickers bar. If you input C4, you get a Kit Kat. If you input D6, you get a Twix. The machine is functioning properly. Functioning, so it is a function. Okay, what if the vending machine company doesn't have enough candy, so they put Twix in E3, A4, and D6? Well, it's still functioning properly. If you punch E3, you get a Twix. If you punch A4, you get a Twix. If you punch D6, you get a Twix. It's still functioning properly, okay? Every input has exactly one output, right? B2 is a Snickers bar. E3 is a Twix bar. Every input has one output. The candy bar that you receive is a function of the button that you push. Now, what if you push C4 and sometimes a Snickers comes out and sometimes a Kit Kat comes out? Well, that's not good. I didn't want a Kit Kat, I wanted a Snickers. So if you push button C4, you're not sure which candy bar you're going to get. That machine is not functioning properly. So it is not a function. The input C4 has multiple outputs. So in order for something to be a function, every input can only have one output. The candy bar that you receive is not a function of the button that you push. Okay, a relation is any set of ordered pairs. For it to be a function is a relation that assigns to each x value exactly one y value. The x values are your inputs. So every input has one output. Every x value has one y value. So there's a way of writing things, and this is called mapping. So the first one is your x's, and notice your x's are 1 and 2, and then your y's are 6 and 7. So if you write them as ordered pairs, you have 1 6, 1 7, and 2 7. Well, this one has a slight problem because when you input 1, your output is 6 and 7. One input can only have one output. Okay, look at this one. Our x's are 1 and 2, our y's are 6 and 7. If we write them as ordered pairs, we have 1 6 and 2 6, okay? So the first one on the left is not a function because the x value of 1 has two different y values. So it's like two different possible candy bars coming out, not a function. On the right side, it is a function because when you input 1, you get 6. When you input 2, you get 6. So this is like the candy bar, the vending machine, where there were 3 buttons that would get you a Twix bar, okay? So it is a function. Okay. The domain is the set of x values, which is your input. So your x's are your inputs. And the x is always the first number in an ordered pair, x comma y. So if your ordered pair is -6, 4, your input, your x value is -6. Your y value, your output, is 4. The range is your set of y values, which is your output values. And it's the second number in your ordered pair. The y value is 4, the range is 4, and the output value is 4. Now we have a list of points. We have 3, -2, 4, 1, -3, -4, 0, 2, and -4, 0. Okay, the domain is your inputs. So the domain is all of the x's. So if you look at each of the pairs and look at just the first number, the domain is 3, 4, -3, 0, and -4. Okay, now the range is the y values. Remember, that's your output. So the y's are going to be the second number in each ordered pair. -2, 1, -4, 2, and 0. Now, it's a function if it assigns for each x value exactly one y value. So if we look at each of the x values, each of them only have one y value. So if you punch 3, you get -2. If you punch 4, you get 1. If you punch -3, you get -4. If you punch 0, you get 2. And if you punch -4, you get 0. So there's only one y value for every x value. So yes, it is a function. Remember that the inputs are your x values. So your inputs are 3, 4, -3, 0, and 4, -4. And then your outputs are the y values. So your outputs are -2, 1, -4, 2, and 0. Okay, given the linear equation y equals 2x, if we make an xy chart, it looks like this. And I'm sorry, it's not lined up correctly. I'll see if I can fix that before class. If we do mapping, we have all of our inputs, and then we have our outputs. And our inputs, remember, are the domain, and our outputs are the range. And then if we write that exact same thing as a set of ordered pairs, notice that we have 3 different ways we can write it. We can do an XY chart, we can do mapping, we can write them as ordered pairs. And notice they're all the same. -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. And again, I'll try and make this line up before class starts. Does this represent a function? So if you look at all of the x's, every x just has one y value that goes with it. So yes, it is a function. Now, if I were to graph it, I want you to notice that it makes a line. Okay, what if we added another point, 1, 2? Would it still be a function? So if we go look at our points, do you notice that we already have the point 1, 2? So if we put another 1, 2 in, aren't we just writing the same point twice? That's fine. Yes, it's still a function. Okay, what if I add the point 1, 3? Well, if I add the point 1, 3, now I have the point 1, 2 and the point 1, 3. This is like where you do the vending machine and you don't know if you're going to get a Snickers or a Twix. That's not right. It's not operating correctly. So no, it's not going to be a function anymore because now I don't know which one it is. Am I going to get a 2 or am I going to get a 3 when my x is 1? So no, it is not a function anymore. So if we look at our first list on the left, we have y equals the absolute value of x. When x is -2, y is 2. When x is -1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Okay, yes, that's a function. Every x has just one y. So it's like when you punch the vending machine, every x, every input value, all of your x's have just one output value. So one specific candy bar would come out. So the one on the left is a function. Okay, now look at the one on the right. When x is 2, y is negative 2. When x is 1, y is negative 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Well, I'm noticing a problem because I noticed that I had x is 2, y is negative 2, and I had x is 2, y is 2, the first point and the last point. Well, that's a problem because this is like where the machine is giving out either a Snickers or a Twix. I don't know which one I'm going to get. That's not okay. I don't want a Twix. I want a Snickers. Okay? So this one is not a function. So if we put our domain in and we put our range in, I want you to notice that when x is 1, when the domain is 1, it's going to 2 different possible numbers. And when x is 2, it's going to 2 different possible numbers. So this is like, there's 2 candy bars. I don't know which one I'm going to get. Now, if you love Twix and you love Snickers, it wouldn't matter, would it? You would be like, I don't care. I'll eat either one. But remember, in order for it to be a function, when you press the button, there can only be 1 candy bar that comes out. That's the definition of a function. Every input has only 1 output. So the one on the right is not a function. Okay, what if this is looking at the graphs. So if you look at the graphs, you can see that both of them look like V's, but one of them is a right side up V and one of them is a sideways V. We're going to talk about that more in the second lesson. Okay, now what we're going to do is we're going to leave the PowerPoint and we're going to go into My Open Math, and you're going to open the notes for 31A. And then you're going to go to question 1. So pause the video and do that. So I'm now assuming that you paused the video and then you got to your My Open Math. So number 1 has a bunch of parts to it. So a relation is any set of ordered pairs. So you're going to type the word pairs there, and then you're going to submit. So a relation is any set of ordered pairs. And then look, see how they gave us an example. XY, 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 okay? So understand, we type yes. And then we submit that part. The X values of ordered pairs, see how the X is in red, are sometimes referred to as the input of a function. So type the word input and then submit. So notice that the X values, the first ones, are highlighted in red, and then in the table, the X's are highlighted in red. So the inputs are the X's. Yes, we understand. Submit. The Y values of the ordered pairs, notice this time the Y is in red, are sometimes referred to as the output of a function. Type the word output and then submit. So if you look, notice that in my ordered pairs this time, it's the second numbers that are in red. That's the Y values. And then in the table, see how the Y values are in red. The Y values are the output. Do we understand? Yes. Submit. A function is a relation that assigns to each input exactly 1 output. Type the word 1 and submit. Tip: if you see a repeat in the input X value and the corresponding output Y value is different, the relation is not a function. Type the word not. Submit. So if you have the same X listed, the same input listed, and when you look over at the output is different, that's the one that's not a function, because that's the one where you don't know what candy bar you're going to get. So if we look at our first example, which says is a function, Notice that x is 1, y is negative 2. X is negative 9, y is 3. X is 5, y is 4. X is negative 19, y is 0. Now look at this one right here, and it's not a function. Okay, 5 goes to negative 2. And then look at over here, 5 goes to 4. That's the problem. That's when they're saying there's 2 possible candy bars. I don't know which one's going to come out. Not functioning properly. Okay, now this one says is a function. And I want you to notice this one has some red in it again. See how we have 5, negative 2? And then we have 5 again, but look, that's still negative 2. So if I list the same one twice, right, that's the same point just listed twice, that's okay. I just listed the same point twice. Yes, it's still a function. And yes, we understand. Okay, now we're looking at 3 tables. So we have my x is 1, y is negative 3. X is 2, y is 2. X is 3, y is negative 3. X is 4, y is 5. And it is a function, okay? Now, you might say, but wait a minute. If you look at the y values, do you see how the negative 3 is listed twice? What that is, that's the example that we did with the vending machine, where if you punch 1, you get a Snickers. If you punch 3, you also get a Snickers. So if they, for some reason, had a bunch of Snickers candy bars, then maybe they put Snickers in 2 different rows in the vending machine. That's okay. As long as I know which candy bar I'm going to get, it's good. Now look at this middle one is not a function. So when x is 2, y is negative 1. When x is 4, y is negative 2. When x is 6, y is negative 3. When x is 4, y is negative 4. Okay, wait a minute. Look, do you notice how 4 is listed twice in the x's? So this is the one where it's like, wait a minute, the candy bar that's coming out isn't the same. So remember, your outputs are different. If your outputs are different, you're saying, I don't know which candy bar the vending machine's going to give me. So this is not a function, because when x is 4, when I put in 4, I don't necessarily get the correct candy bar. Now look over at this one. When x is 2, y is negative 1. When x is 4, y is negative 2. When x is 6, y is negative 3. When x is 4, y is negative 2. Okay, notice that 4 is listed twice in the x's. But if you look at our y values, the outputs are the same. So all we did was just write the same point twice. That's fine. That's still a function. So remember, same x has to have same y. Same x has to have same y. So yes, I understand. And then submit the question. Now we go on to number 2. Okay, number 2, it says a function is defined in the table below. Using the table, identify the input and output of the function. Separate the values with a comma. So what we're going to do is we're going to click our cursor into the inputs, and the inputs, remember, are the x's. So if you look at our table, do you notice that our x's are negative 23, negative 22? So we're going to type negative 23, comma, negative 22, comma, negative 5, comma, 20, comma, 42, comma, 47. Now we click to the outputs, and the outputs are the y values. So we're going to type 55, comma, 43, comma, 52, comma, 40, comma, 19, comma, 87. So the inputs are the x's, the outputs are the y's, and we submit. Number 3. Each set of ordered pairs, x, y, represents a relationship with input x and output y. Select all relations that represent a function. Okay, once you get to this point, okay, what you do is you want to look at your x values. So I have 0, 2, 2. Okay, wait a minute. Notice how we have 2 2's. So now I have to look at the y values. When x is 2, y is 1. When x is 2, y is 6. That's a problem. Because remember, that is telling me I don't know which candy bar is coming out. The machine is not functioning properly. So G is not a function. Let's go down to the second one, S. Okay, X is -2, Y is -3, X is 3, Y is 1, X is 6, Y is 5, X is -2. Okay, wait a minute. I already had a -2 right there. So I've got to compare the Y's. -2, -3, -2, -3. That's allowed. Remember, that's just the same point listed twice. So that's fine. And then 11, 16. So yes, every X has only one Y. So if I'm at this vending machine, when I punch the input, I always get the candy bar that I wanted. Okay, now look at F. -4, -3, 2, 1, 6, 4, 7, 9, and 16, 13. Okay, all the X's are only listed one time. We're good. It's a function. Okay, now the last one, R, 0, -3, 1, 2, 6, 4, 9, 7, 12, 14. See how all the X's are different. All the inputs are different. 0, 1, 6, 9, and 12. Yes, that's a function. Submit. Number 4. Okay, number 4 is the same as number 3, except instead of a list of points, it's a table. So now we're going to look at our X values in the table. -3, 3, 4, 9, 11. Okay, see how all the X's are different? Yes, it's a function. Next table, -4, 2, 2. Whoa. Now I got to go look. Okay, when X is 2, Y is 3. So that's like I punch 2, I get a Snickers. Then it says when X is 2, Y is 5. Wait a minute, that doesn't work because that means I punch 2, I get a Kit Kat. That's not going to help me. So no, not a function. Okay, 0, 2, 6, 8, 2. Okay, wait, 2 is listed twice. So over here it's 2, 3, 2, 3. Oh, same point. It's all, that's fine. Punch 2, get a Snickers. Punch 2, get a Snickers. That works. We're good. Okay, X's are -3, 2, 5, 7, and 12. Okay, every X is different, so every X has one Y. Now, do you notice that on this one, when X is 2, Y is 1, and when X is 5, Y is 1? Remember, that's like the vending machine where they had too many of one kind of candy bar. So they filled up 2 rows with the same candy. So there's Snickers in row 2, there's Snickers in row 5. So if you punch 2, you get a Snickers. If you punch 5, you get a Snickers. That's fine. Because remember, as long as I know when I punch 2, I know what candy bar I'm going to get, it's all good. It is a function. Okay, now we're back to this one again where it's a list of points. Same exact thing. So I look at my X's. -5, 2, whoa, lost my mouse, give me a sec. -5, 2, 4, 7, and 15. Every X is only listed one time, so yep, it's a function. Okay, letter G, -4, 2, 2, 2, 3, 2, 6. Different Y values, not a function, don't select it. Okay, -5, 2, 5, -5 is twice. -5, -3, -5, 7. Nope, not a function. Remember, I have to get the same candy bar if I punch the same number. Okay, now we look at the last one. 0, 2, 6, 7, 0. 0, -2, 0, 11. Nope, when I punch 0, I don't know which candy bar I'm getting, not a function. So on this one, R is the only one that is a function. Number 6. This one I would like you to look at, and I'm going to wait just a moment, and I want you to see if you can do it. Actually, no. Pause the video and see if you can answer this one. Okay, so I'm assuming that you paused the video. And so I'm going to tell you that the first one is a function because all the X's are just listed one time. Okay, the second one is also a function, because x is 2 twice, but look, it's 2, 3, and then 2, 3, so it's the same one listed twice. Okay, this one is a function. Every x is just listed one time. And then this one is a function also. All the x's are only listed once. All the inputs are only listed one time. So all of them are functions. Okay, number 7, pause the video and you do it. Okay, so I'm assuming that you paused the video. So this one is a function, 3, 7, 13, we're good. 3, 7, 7, 7, 6, and 7, 14, nope, not a function. And then 3, 7, 13, yep, it's a function. So even though there's 6 listed twice, remember, if I punch 7, I get a Snickers. If I punch 13, I get a Snickers. It's all good. That just means they put Snickers in 2 different rows. Okay, now, for this one, this is a review of what we did last semester, okay? So I want you to come down to the bottom right here where it says add work, and I want you to click that, and we're going to type something right here. So you're going to type y equals mx plus b. M equals slope, b equals y-intercept. Okay, now I'm going to type the equation y equals 2/5 x minus 3. Y equals 2/5 x minus 3.
Just want to say bye.
Bye.
Talk tomorrow.
M equals 2/5. B equals -3. So now we are ready to graph it. When you graph it, so make sure you type this into your notes. When you graph it, you always start with the y-intercept. So we're going to put a dot at -3 on the graph. Okay? So we're going to come up to the graph and we're going to put a dot at -3. So we always start with our y-intercept. Then our slope is 2/5. So we're going to start at our dot and we're going to go up to, right, 1, 2, 3, 4, 5. And that is our line. So first we plot the y-intercept, then we do the slope. And we submit and go on. Okay, now go into your work area. Y equals mx plus b. M equals slope. B equals y-intercept. Y equals -1/5 x plus 2. -1/5 x plus 2. Okay, M equals B equals. Okay, everybody pause the video and type in the M and the B. Okay, I'm hoping for the M you wrote -1/5, and for the B I'm hoping you wrote 2. Now pause the video again and go graph it. Okay, so we always start with the B, the y-intercept. So we need to put a dot at 2. And then our slope is -1/5. So from our dot, we're going to go down 1 because it's negative, and then right 5. 2, 3, 4, 5. And submit. And then finally, the last one, click your add work. Y equals mx plus b. M equals slope. B equals y-intercept. Y equals negative 3x plus 5, negative 3x plus 5, m equals b equals. Okay, pause the video and type in your m and your b. I'm hoping you typed negative 3 for your m and 5 for your b. Pause the video one more time and graph it. Okay, so we always start with the b, which is 5. So we have a dot at 5. And our slope is negative 3. Now, when our slope is a whole number, we make it a fraction. So it's negative 3 over 1. So we go down 3, right 1. And we submit. And we are done. And now you're going to go work on homework number 31. And have a wonderful day. Thank you.